Hello guys, in today's episode. Today I want to talk about the 555 timer, which is one of the most popular ICs. It was invented in the 1971 and it is very popular up to today. Here I have a little diagram of the pinout, but it is used mainly to generate constant frequency square wave, which can be modulated a bit with some filters to other waveforms, but the biggest use of it is just to generate constant frequency signal. Here we have few pins. The 1 and 8 pin is, as you can see, the supply voltage. On the first one we connect our ground, on the 8th one we connect our supply voltage. Then we have the trigger pin. If we apply very little voltage to this pin, it will activate the internal timer circuitry. The third one is just the output of our wave. The wave, if everything is connected in a good way, and we will supply the voltage to the 1 and 8, we have the output waveform on the third pin. The fourth one is reset. If we will connect anything to it, if we will turn it into the high state, it will reset all the internal circuitry and discharge the caps that are connected externally. And then we have the control voltage. This is not used very much in our circuits. This is the pin 5, and we just connect it through 0.01 microfarad capacitor, which is 10 nanofarad cap, to the ground. Then we have the threshold voltage, which is just the voltage. To the discharge pin we mainly connect capacitor, on which our frequency is dependent, and to the threshold we connect the voltage on which the cycle should start repeat. So on the discharge pin we discharge the cap through it, so the capacitor raises the voltage to a certain level, then we discharge it through the discharge pin on a certain level that is regulated by the threshold voltage, and then the cycle repeats. And that's the mainly whole purpose of the 555 timer. So let me show you what we got inside of our IC in a little book, and then we will start building something with it, and I will show you a schematics of some vibrators and oscillators with it. Here I have the internal construction of the NE555 timer. It is pretty simple but complicated a bit. So what we have here is mainly 3 comparators, flip-flop, NPN transistor, and voltage divider. So as you can see, in between of the VCC and ground we have voltage divider, which consists of 3 5 kilo ohm resistors, and this is how the NE555 is called 555. Here we have the control, as you can see, connected to the minus input of the comparator. Here we have the trigger connected to this comparator, threshold connected in here, and then based on these 2 inputs, the flip-flop, which is RS flip-flop, can be flipped on or off, and the reset pin is just connected to this flip-flop, and when we pull up the reset pin high, it just resets the flip-flop to the normal state. And then the output is, as you can see, connected to the discharge, so when there is a signal on the output of the flip-flop, it opens the NPN transistor, so the current can flow from the collector to the emitter, and then the capacitor is mainly discharging to the ground. And the output is just, on the output we have little inverter which inverts the signal, and then we have our output. Pretty simple, I think. So let's get to circuits that we can build with this thing. So this is the first circuit that we are going to build today based on the 555 timer, which is called iStable multi-vibrator, and it is sometimes called just oscillator because this is the circuit. The frequency of the output, here we have our output, is based on those three values, R1, R2 and C1. And here we have the waveform and how it looks like when it comes out of the pin 3. Here we have the voltage over time graph. Here we have the high state, which can be, for example, 5 volts, but it depends, on the supply voltage. So here we have the time that the impulse is high and the time that the impulse is low, and this is our full cycle. If you want to calculate the frequency of this oscillator, you need to get the value of the resistor 1 or of the resistor 2 and the cap 1. Here you get the time of the full cycle, and this is the formula for that. Again, R1, R2, C1. Here we have the formula for the time that our impulse is high, and here we have the formula that shows us the time when our impulse is low. So let's build it. So now I have built the iStable multi-vibrator, and instead of the R1 I have used 220 kilo ohm resistor. Instead of the R2 I used 220 kilo ohm resistor, and the C1 is 10 microfarad. And that's pretty much it. Here we have the circuit. If I will stop the oscilloscope, you are not able to see anything. Now it should be better without the light. As you can see, our whole impulse of the voltage is mainly, as you can see here, we have 1, 2, 3, 4, 5, 6, roughly 6, which means nearly 2 seconds, 6, nearly 7, so 2.5 seconds of a impulse. So it's pretty long duration, as you can see. And this oscillation of this iStable multi-vibrator is mainly dependent on those resistor values, as I said before, and on the capacitor. If now I will replace the 10 microfarad, turn off the power supply and replace 10 microfarad with 1 microfarad, like that, put it in here, it will oscillate faster. As you can see, it oscillates faster now. Now we can increase the speed of the time base, and we will be able to measure the single cycle, which is roughly 0.3 seconds. So this is mainly the iStable multi-vibrator, pretty simple configuration of the 555 timer. You can use it to virtually anything. After presentation I will show you some practical examples. Here I have connected little power supply for breadboard, which powers up all the lines, if you are asking, and I am connecting here DC jack from my little 9 volt battery pack, which I have made. It is just a case with 9 volt inside to just make it look neat, and that's pretty much the whole principle of iStable multi-vibrator. So let's now get to another configuration. So let's now examine the monostable multi-vibrator. The schematic is pretty similar, but now we don't have two resistors, but we have one resistor. And here we have 10 kilo ohm resistor. Here we connect switch to the ground. This capacitor goes to the ground, ground. And in this configuration, the pin 3 will release impulses every time we press a button. So for example, duration, let's say, of our button click is like that. We have clicked button like that, and the duration of the impulse can be like that. So the impulse is independent of the switching button. So this is what you can do with this circuit. Let's now build it. So here is our circuit. Here I have the button with which we can release the impulse. I am on the normal triggering mode, so it will trigger on a 2.2 volts that I have set it on a rising edge of the waveform. And now if I will press the button, as you can see, it triggers, it catches the waveform, and now we can switch to the vertical scrolling. We can scroll to the right, and as you can see, this is our impulse. Of course it is pretty short, so let's do this again. As you can see, on a low setting, my scope, as you can see, low time base, it doesn't pick up this. But when I will crank up this to the level when it is constantly drawing the waveform, and I will switch to the normal, as you can see, it grabs the waveform normally. But when I will switch to the on a higher frequency too, but it doesn't catch this on a low frequency, so we will need to catch this manually. What I mean with manually, if I will increase the time like that, just hop on, and it is like 0.3 seconds, which is the normal cycle that we had before in our configuration. So as you can see, it's working pretty well. The configuration, the cap that I have replaced the last time from the 10 microfarad to 1 microfarad, it is now 1 microfarad like before, and 220 kilo ohm resistor. I can replace the 1 microfarad, of course with a turned off power supply, to 10 microfarad, and our impulse should be a bit better, should be a bit longer. So we connect it, turn it on, and as you can see, the whole impulse is just so long that I need to change the time base. Something disconnected. That's when doing electronics, you know. Something is always disconnecting. As you can see, there's a problem of the resistor, that's why the LED doesn't blink. So let me just show you this with a single LED. So now when I have increased the capacitance of the capacitor 10 times, as you can see, if I will, let's wait for it a bit, and now see how long the LED is shining, and then it turns off. So you can build few things with it, for example a impulse generator when you will replace the switch with a transistor, decrease a bit the capacitance value, and then based on this you can make a impulse generator. So that's pretty nice. Let's now get onto the another use. Okay, so this is another use with a schematic and practical example right away because it's pretty simple. So this is bistable multi-vibrator, but this time it doesn't oscillate. We are just using the internal flip-flop of the 555 timer, and we have just two buttons. The one that is connected to the fourth pin, it just resets the IC, and this one just pulls in the voltage to the second pin, to the trigger pin, and it makes the flip-flop flip. So here I have the button that activates it, and here the reset button, and this is working. We are just using the internal flip-flop for doing this. Pretty simple, isn't it? So let's measure some voltages of this configuration, because in the last ones we were mainly generating the signals and it was depending on some other stuff, but let's now measure the voltage drop that we have here. So here is the multimeter, and here I am measuring now the supply voltage, of course in reverse, 4.9 volts, pretty nice. 4.9 volts. Let's now turn on the flip-flop, and now the voltage that we have on the output is 3.5 volts. So it's pretty nice, pretty okay, I can tell. And on the turned off state, it is completely disconnected from, yeah, it is nearly completely disconnected from supply voltage. So mainly this is how this flip-flop is working. Of course you can connect2 of those two buttons. I don't have any example right now, but you can connect instead of 2 switches, one two-way switch that will switch between the trigger and the reset pin, like that, and it will be a bit better. This can be used normally as a flip-flop in your projects, that when something, for example a transistor, will be opened, you will know that for example an alarm system or something like that, when someone opened the door and you don't want to let him know with an alarm, you can just make a flip-flop like that. So you just zero it, and then when someone enters the room that you have protected with an alarm, you can connect the contactron magnet read switch, and then when the power is connected to the base of the NPN transistor, for example in here, it shorts this thing to ground, and you can see the LED flashing, just shining. So that's pretty much the only use of this flip-flop. And now I will show you some of the projects that I have made myself. So here I have little kit that I have bought at my local electronic shop, and this is a square wave generator, and it is mainly based on the 555 timer. Here I have somewhere the schematic. Sorry for the microphone. Here I have the schematic of it. It looks like that. So it's mainly based on the 555 timer. And here the capacitor that in our circuit we were connecting. Here we can change them and we can fine-tune the frequency, fine-tune the amplitude with this potentiometer, and fine-tune the PWM modulation, just the duty cycle of the wave. So here you have PCB, assembled stuff, and here we can change the range of the frequencies. So now we are set it on the third frequency range, which is pretty high because the capacitors are getting smaller and smaller when getting to the more to the left. So let's turn on the power supply. We are on 12 volts on the power supply. We are connecting the output to the scope, but the RCA jack that I am using doesn't contact very well. And here because he doesn't like me. Sorry for a moment, I will repair the RCA jack and then we will get up to the... So I'm back. I have replaced the way that I'm connecting the signal to the scope. With this potentiometer we can tune the amplitude. It has some problems on special exact point of the potentiometer is like burned and it doesn't want to contact fairly well and it disappears, but mainly that's some kind of fried up potentiometer. Here we have the duty cycle, but this duty cycle is regulated not very good in here, because as you can see the duty cycle is changing with the frequency knob too, so that's not very good example, but it is good enough square wave generator for me. It is powered from 12 volts, so that's a pretty useful thing. And now I will show you one of my Instructables that I have built, which is a little PWM signal generator and then another oscillator like this one, but this one has 3 knobs, but my first solution in this way was with just the switches. So see you. So I'm back. Here I have a little PWM signal generator which works pretty nicely, as you can see. It works in a frequency of roughly 150 Hertz, which is not very fast, but it's enough to control the speed of the motors and brightness of LEDs, so that's pretty nice. And this is just a simple, and it is based on 5555 timer still, so you can build something like that with a 555 timer. So now I will connect power and oscilloscope to my first ever square wave variable frequency generator that I have built. So see you in a moment. So this is this oscillator, and what I have done here, we have a little jumper with which we can select the frequencies, and at the output we have single LED. And the first cap that I have here, as you can see, it blinks very slowly. Then we have, I believe, 10 microfarad capacitor, then 100 nanofarad. As you can see, this is 100 nanofarad, 10 nanofarad, I think, one nanofarad. This is 1 nanofarad. Wait a moment, I need to tune the scope. This is, as you can see, 10 kilohertz square wave. This is somewhere around 10 nanofarad, and then 100 picofarad. And as you can see, it doesn't work nicely in this frequency. This is not the, you know, like problem of my scope very much, because it is like the half of the bandwidth. So this is just the problem of this oscillator. You know, it has a lot of wires, so it picks up some noise around, and the capacitor, you know, is old. Those caps are old. They charge and discharge, you know, 1,000 times a second, so that's pretty much it. But besides that, this was the first ever generator that I had, and I was switching on and off transistors with it, MOSFETs and some other stuff. So I hope you enjoyed this video. I have made a little bigger project with 555 timer, which is a little piano. I have made Instructable about it, so if you want to see it, you can go on my channel. There is a little presentation video of this circuit, and if you want to read a bit more about it, you can go onto my website, and on my website you have link to Instructable. So that's pretty much wraps it up for the 555 timer. It is the most useful I think I see, because for example, you know, when you just want to turn on and off things in a certain periods of time, or generate PWM signal, you know, everyone will mainly say use a microcontroller. But microcontrollers such as the Arduino Uno microcontroller, which is Atmega 328 PPU, 80 mega 328 PPU, and it has like a 13 digital pins and 5 analog inputs. So it is just too much. Sometimes you just want to turn on something, turn off, or just make a simple flip-flop or something like that. So sometimes it is just easier to do it in an analog, old-fashioned way with 555 timer instead of programming whole Arduino Uno and wasting all the other 10 pins or something like that. So I hope this video was useful for you. Maybe you will build something like that by yourself. And see you next time. If you want to see more videos like that, please visit my website ardugeek.pl.